hold on, this computer, and we are recording. So the code from yesterday, I think recall I dropped the code when I had it in a code snippet that had both of the classes together, and I also dropped the zip files for the individual classes like was requested. So for today will be an extension of yesterday. We'll be going over mostly inheritance and composition, even though we've already unknowingly discussed composition or seen composition in use. So if you want to follow along with the code, pull that code up, and I will be just adding to the code and using the code, like I said, that we did yesterday with the store, where we had a store with a name. We had different departments or categories in that store. And when we were brainstorming and asking questions the other day in kind of emulating the first step of Poly, is when I presented the problem, some people mentioned, well, wouldn't each department have different products? And that's what we come to today using class and inheritance, and we will talk all about inheritance, association, composition, and all those good things. So I'm going to do a quick survey. Everybody that's in here, 9 people in here, answered. Did everyone watch the pre-class videos? Yes, no, some. What videos? Anybody else that hadn't answered the survey, answer it. Got 9 people in here and 6 people have answered it. All right, well, it looks like everybody's watched the videos. It's answered. So yesterday we started talking about classes. We showed an example where we made some basic classes, used a class within a class. There's 2 primary ways that we will go about. There's a lot of object-oriented programming is vast. It gets complicated at times. We're not going to be able to have the time to cover all of it here, but we definitely want in the curriculum to include a great deal about it. So as far as in general in the industry as well as here, you will see 2 very common relationships that are established between classes, and those relationships usually are inheritance and association, or composition, excuse me. And we've already seen composition yesterday. Who can tell me how we saw composition yesterday? Turn on your mic, you can type. Where did we see composition yesterday? So inheritance, if you don't recall, or it's, inheritance is where We specifically use syntax. Somebody asked about the super. We were talking about inheritance the other day. We've seen it in other languages. We're actually using syntax to inherit a parent and the methods and attributes associated with it. But in this case, composition. Where did we see composition yesterday? A different type of relationship. Anybody? I'm going to share my screen. So remember yesterday we had the category and we had the store. And right here in the store, when we instantiate the store object, we actually call category inside of it. There was no inheritance that occurred here. There was no explicit inheritance, but we instantiate another class within a class, and this is known as composition. Different trains of thought on it. There are some schools, and I don't mean literally a school, but just schools of thought that composition is preferable. There are other schools of thought that would say inheritance is preferable, but know that composition, we've already seen it, it's simply calling this class within a class, instantiation of a class within another class. That should be pretty clear from what we've already gone over, what you've looked at. If anybody has any questions about that, post it in the channel now. So I guess in short, you could say store, the class store has a category class within it. It didn't inherit it, but it utilizes, it instantiates this category class that we imported from right here. Going to go ahead and start coding. Today we're going to have another class for products. So let's say class, product, remember my colon, and here in Python, what would be the next thing that I need to do for this class? What kind of syntax do I need for this class? Somebody talk or type. What do we need? There's something in every class that we need. Something we talked about in detail the other day. Ah, there we go. Uninit. And what's the first thing that we always have in init?
Self.
Cool. And we will give a product a name and a price. What are these called here? The name and the price. We're gonna assign them to something here. What attributes? Thank you, Jawad. Very good, attributes. So how do we call this attribute? It's specific syntax we're gonna have to use. We just can't say name equals. What do we need to do? Self. If I can spell right. Do you ever laugh about my typing? I'm 38 years old. I used Hunt and Peck for 36 of those years, and I actually learned how to touch type right before I learned how to program, so my typing kind of sucks. What's missing here? Why am I throwing up these errors? There's something missing that I specifically left out intentionally with the init. It's on line 2. What did I do?
Def. DEF.
Yep. And somebody in their own words describe to me what this method, what did we call them the other day? Special methods that we found in the documentation. Somebody referred to them as magic methods in an article, but I think they referred to them as special. And what does this allow us to do, this STR? What does this allow us to do with the object that this class consists of, the product? Allows us to do something specific with print statements, with a string. Format it. Yeah, it allows us to return certain attribute values without it printing with weird syntax. Yeah, if you just said, outside of here, say we had instantiated this class product and we just said, let's say we had named it, y equals product, and we gave it, whatever and whatever. And then we went here and we said print y. Like Jawad is pointing out, we get this, the format, it's a weird syntax that comes out of that. So this allows us to basically represent this object, the attributes of it, like Jocelyn's saying, we can format how we want it to look. We're able to represent it as a string. We're able to represent it in a readable format like we did the other day over here in the store where we created this output that we saw in the command line. If you that we saw. So remember yesterday, got a little bit of a problem that I want to fix now before I forget about it later. I need to make sure these are all in the same directories. Okay, so now we should be able to run the store. And remember, we had this output that we were able to interface with, and that's all we're doing. So that's all that this STR, I know there was a lot of questions about it yesterday, but just trying to go back over some concepts that we covered yesterday that there were questions over, and just trying to reinforce certain concepts that we will see again and again and again and again and again. So here, we are wanting to be able to represent this product, so we will give it a return of self.name plus a backslash $. What does this backslash do? Same thing it does in another language. What is that? It's one word. Starts with an E. Somebody type.
Escape.
Yeah, it's escaping. Anybody know what this particular is doing in this escape with this T in Python? syntax? It's a tab. So all I'm doing here is I'm doing a name and then I'm just tabbing over a space. So I have a tab distance between it and then the $sign, and then we're adding the price from self.price. And why do we add this str in front of the price? I know a lot of the questions I'm asking are basic, but I want to go over, this is an intro week and I'm going to take all the chance I get to go over the syntax itself and not just the current concept that we're covering. Why is that str in front of self.price? We talked about this yesterday.
You're casting it because it's going to be written as a string and it's an integer.
Correct. So we are just making this all into a string. So now that we've got a product, we've got a store, and we have departments within that store, categories. I should have just named that department. We got categories within that store, and we've got products. What type of classes might we make now, since we're making inheritance, that will inherit from product? Every product is going to have a name and a price, but there'll be different types that maybe some may have a size and some may have a weight, some may have anything, any attribute, any type of attribute. So the goal here that we're working towards is this product, we're going to inherit name and price. So we don't have to deal with defining this again. All products have a name and price, yet the children of these products that will inherit the attributes of the product and inherit this as well from the product, even though it can be overridden, the string method. What kind of products could we make? Somebody just throw some things out. What kind of products are we going to have in our store?
That relate to the like the departments that we have.
Yeah, well, I guess what I'm thinking is, say the departments that we've had so far. So the categories, if you recall that we've got groceries, electronics, and clothing. So within groceries and electronics and clothing, now we have another class of products. So let's say, for example, in electronics, a class of product could be televisions. It could be game systems. It could be laptops. And then each of those will have attributes on their own. Is everybody following what we're doing here in general? If not, speak up. Okay, so I'm going to make a new file, and we will make, say, from product, import product. Remember this syntax from yesterday. I named that wrong, so it's from project, import product. I'll fix that later. We will call this laptops. All right, so for this, we'll have to have the init as usual after we do the class. So we'll say class, and we will say laptops. Then to inherit it, we will simply put product right there. This syntax is we imported product from the file that I did not name correctly, and I'll fix that naming in a bit before I distribute these, but we're importing this, and then as we are creating a new class of laptops, we are inheriting product from it. So we're going to need an init, and in that init, what all are we going to have to take in here? Remember, we're inheriting products. So what will we have to do here specifically? All the attributes from products. So let's go back and look at product. We had a name and a price. So we're going to take in a name, a price, and then for laptops, what? Give me two attributes to put for a laptop. Anything reasonable.
Features.
Features. Wait. Features, let's be a little bit more specific. How about, we'll say size, screen dimension, but we'll just say size. Everybody good with that? But yeah, all these features that are specific to a laptop, because some of our other products, because we have such a general apparent class of products, all products do have that name and price, but this allows us to have specific attributes that are only specific or more specific to a more specific product. And I think I just used the word specific way too many times. But now the next piece, does anybody know what goes here? We have to do something because we inherited product. We got a name and a price, but we need to do something. Someone asked about this word specifically yesterday. Super.
Super. Oh, sorry.
Super. And then what are we going to do? We're going to call super, but what else after that? What are we going to do after super? Super is giving us access. Yeah, exactly. And super is giving us access to the parent. Now, if there's more than one parent, if there's multiple inheritance, it begins to get a little bit more complicated, and you can run into quite a few different problems. Simply put, let's say we had more than one class here. Python will literally look at this left to right, and it will start looking for whatever. So if we call super.init here with no other specific syntax, and we'll say name and price because that's what we need for it. But say we had two classes here. Super init would look for init in product first because it appears, because product has an init, of course, that's the init it's going to use. This is where inheritance and object-oriented programming starts to get a little bit complex. You can Google, if you want, MOR Python, and that will, you can probably find a lot on that. Speaks of the order that it resolves. something of this nature and how it moves left to right, how you can override that. We're going to talk a little bit more about that later, but for now, we'll just leave it that we're inheriting from one parent. We call the init. This is initializing the parent with the name and the price. We've got to do this. Then after that, what do we need to do? What do we probably want to do? We've dealt with the parent. Now what would be intuitive to do? If I ask a question and I'm silent, just assume I'm saying somebody talk, somebody type, because I can sit here and drink coffee for a bit.
I have to add the self to the name and price.
You don't have to mess with the name and price, because think about it. What we're doing here, we're calling init, and it's going to call the init on product. So this goes back to product. We're giving it a name and price, so now we're initializing it. So that's being taken care of here. That makes sense? What about our weight and size for our laptop? You want to maybe call do something like that. And you don't, one thing I want to point out about the super, we're inside the init here. The super can be used outside of the init. We could come down here and we could define something totally different. We could define our own customized function. We could define, the string representation here. Anywhere that inside of this class, you can invoke super to access the parent. Just want to make that clear. We can also something else I want to cover is that we can override inheritance. So for example, remember that the product has a string, this special function here that allows us to return a string from it. Let's make a new file. We have laptops. Let's go back to our store, electronics. We have groceries. We have clothing. So for this, what kind of clothing do we want? So the first thing we're going to have to do, say from my horribly named project, import product. Something else I wanted to point out, if somebody ever sees anything that I'm doing and they know a faster way to do it within VS Code, within the terminal or whatever, feel free to point it out. I honestly didn't know until yesterday that you could right click like this and run. Whoever pointed that out for me and run it in the terminal. As many times as I've been in this damn screen, I never did notice or pick up on the fact you could run it like that. But so anytime something like that comes up, feel free. And we're going to save this as onto the desktop. Clothing. What can we say for clothing? We're going to have shirts. Make it something easy. So we'll make a class for shirts. We will inherit product from it. What are we going to do here? We're going to have another init. Self. name, price, and we'll say for shirts, we will have,
Size.
yeah, we can have size, color. I think that looks good. Then we will have our super, and we will call our init, and we will have the name and the price. So that handles the name and price. Self.size equals size. Now, whole point of me doing this was we got a problem here. If we want to be able to use the special function string here, what is the problem? Someone talk. We want to be able to use the string here, but what sort of a problem do we come about with that? Or I don't like the word problem. What issue, what implication? We inherited from product. We inherited, remember, everything from product. Somebody, anybody?
I don't think we're going to have an issue.
There's not an issue. Well, there's not an issue, but there's, and Esteban said there's already a string method. So you can override that method, but no, if you were to, now, there's not an issue because it's been inherited, but if we want to write a new string method, we can even do something like this. You could call super, and what this will do is this will give us what's here, so it will return the name and the price. So it could, let's just say, the, I don't know, t-shirt that is $14.99. That's coming from the super, plus space comes in, plus self.color, plus, and we'll say string. We're not going to use string there. We'll just say self.size, because we'll assume size is going to be in like small, medium, large, and we don't have a numeric size for shirts. So you're right. We did not have an issue with this. The only thing to consider, and I think I worded that badly, and I apologize about that. It's why I started to backtrack onto when I said, well, it's not really an issue, but it's something to consider. We already have a string method that is part of the parent, so we can actually access that method through super right here, and have our own string method here. So if we were to invoke a print on shirts, what you would actually get would be everything that was here that I'd already highlighted, plus everything that we've made here. That makes sense. Anybody have any questions about anything we've gone over so far? Any terminology? I'm gonna make a. And you can just say no if you don't have any questions. It's anonymous. Type the questions up under. Let me give you all a few minutes to mess with that.
I would like to learn if we are inheriting from two objects and we want to override one of those objects string representation. How could we differentiate that which one we want to override?
Okay, so you're meaning if you have, hold on a second here, might be easier just to draw really ugly. Where is the text draw? We'll say fine line with red. So you are, let me make sure, asking, say we have a parent here, A, and a parent, B, and you're saying we have a child here, C, that's inheriting from both parents, and both parents have a string method, and we're going to use super here. Which one does it invoke? Or if we override it, which one will be overridden? I just want to make sure I understand your question.
Yeah, I would learn both. If we just want to print the C, which one will print string representation of A or B, and if you want to override, how could we choose that we want to override A or B?
Okay, so let me clear this. So for example, if down here up under this, say we wanted to say A equals shirt, and we're going to give the shirt a name of, we'll say self t-shirt, t-shirt, price is $9.99, size is large, color is white. Now you're saying for this, you're saying for this, if we invoked, let's say we inherited both up here, product, and I'm just going to name it like I did before, second. God darn it. You're saying that if now within shirt, if I invoked if I'm invoking super here, if both of these have a string method, which method will this invoke here? Is that what you were first asking?
Yes.
Okay.
Yes.
The first thing on that is according to the methodology which it resolves inheritance, Python will read left to right. So if you call super within this class and you have inherited from both of these classes, this one being a theoretical class that does not exist, but they both have a string method on it, Python moves left to right. So first it looks here. If there is no string method here, then it moves to here. If there's no string method here, then it gets into some weird, complicated ways, and it'll throw an exception. It won't do, I guess theoretically it can do something, but it will throw an exception for readability and for kind of the simplicity that Python tries to do. So if you call super on that, it will get it from product. Say we wanted it to get it from second, you could simply rearrange these. Or
So Python objects can inherit from use one of those superclasses initializer.
So you're talking about if you inherit from multiple classes, how you would use the initializer here.
Yeah, I want to use the superclass methods like initializer or string representation. So we can only use one of those, right? We couldn't do both, or we couldn't choose which one we want. It just allow us to use the first superclasses methods to use.
So you're asking that because there's multiple inheritance, that how we call the init on both of the classes.
Yes.
Okay. I'm going to have to look at this. This is not part of what I was planning to get into. I think I know the answer, but I do not want to give you the wrong answer. So give me 1 second to make sure I've got the correct answer, okay?
Sure.
Like I said, and what I was speaking of earlier, what I've just run across is that a real long-winded description of all this. It's called the method resolution order, the MRO. So I was saying methodology. It's method resolution order, and that talks about the order that Python will read these in. How to actually access all these, I'm making sure right now that I give the correct answer. It's right at the hour, so I'm going to let everybody take a 5-minute break while I am double checking on this, and everybody meet back at 5 after the hour. So it's your time, 10:05 Lambda time. Come back, okay?
Hey, Jonathan.
Yeah.
So I just wanted to make sure that you understand my question. So let's say the second class also have a color attribute, and also it has an initializer which it gets assigned the color. And I want to use the second class's initializer and pass my color attribute to it. So how can I use it? So I want to use first the initializer of product and pass my name and price, and then I want to use the second class's initializer pass my color attribute.
So you're saying that because, let's say, second already had a color and then we have a color here as well, you were wondering what happens with line 7?
No. I just want to use the second class's initializer, and I want to pass something to it.
And that's what I understand what you're saying. I'm looking right now to make sure I give the right way. There's a way in the parens to call it, but I want to make sure I give the right answer because this is beyond what I had planned on covering. So I don't want to give you.
Sorry about that.
Oh, it's okay. No, not at all.
Complicated. I can look at it later.
It's not. I just want to make sure that now what does get complicated is, say, when you inherit two different things from two different classes and you start to override things and you have multiple inheritance and you're overriding, that gets complicated. It gets very complicated. And that's where that method of that MOR that I was talking about really comes into play. And I'm reading right now about how this works. Okay. I am going to go ahead and reshare my screen. And is everybody seeing my screen again? Okay. It's kind of, this is going to throw a weird error. Well, not an error, but it's going to throw something weird in. But what you would do, so the question that was being asked, I think there was several questions going on, but one of the questions being asked is, say we are taking in both product and second here, and we want to call the initializer on product and on second. If you call super, super will refer to the parent class. Another way that you could do this is you could say product.init name price. This second doesn't exist and it's going to throw an exception, but we could say second init and then say second had, I don't know, X and Y that we're bringing in. This is how you would initialize both the inherited classes. This is a way that you can access any of the parents. If you simply use super, the method of the MRO that I spoke of, the method resolution order will take effect. And so if right here you just use super, it's going to use products init. If second was first, then it would use seconds init because it's reading left to right. This wasn't included today because this gets into some of the very complicated things that a lot of times you just have to read about. You've got to work through it in the code to see how it works. But in general, if you don't specify anything and you call super, it's going to read left to right here, and it's going to, the first place that it encounters whatever you're trying to access, that's what it will use. If it does not encounter anything, it will throw an exception. So for that piece of the question, does that make sense?
Yeah, totally. Thanks so much.
Okay, the next. And then what was the other piece of your question? I know you had another piece of the question. That should answer that. And then
So I think it makes sense right now. If we
okay.
are using the super.str, it's going to use the product.
It's going to follow the MOR, which will go left to right. So it's going to look for an init in product. Product has an init. Now, say we wanted to call a specific method that was on product in second. And some of these things are things that you've got to think out when you are using object-oriented programming. You've got to think out, how am I structuring this? How am I ordering the inheritance? How am I naming things? Am I naming things semantically? Am I giving things unique names? And that's very important because you wouldn't want to name a method necessarily the same. If you were inheriting from 3 different parents, you wouldn't want to have the same method in each parent or even the same attribute where you even have these problems. So part of it could be preventing the problem before it happens. Things like init that we're going to be dealing with all of them. The reason I went to go read is I had something in my brain, and it was something with Python in the past. I think Python 2, you actually in the super could put, I think, product right there. I don't know if this will work right here, and we don't quite have the code set up to run this right now, but I do definitely know that you can do product.init name price and then second dot init name price. That makes sense? if you had a color, if you were saying if you inherited the same attribute from more than one parent, that gets problematic and complex. That is worth your time of reading over the MOR, and I would personally look at trying to avoid that before that ever even happened. It might be a question for the Q&A that would be good. I'm sure an instructor might be able to have a much simpler or quicker way of explaining it, but that's something that I'm not ready to dive into right now. I think the big thing for today is just looking to see how an inheritance works. We talked about composition, where we, like when we had the store and we simply are invoking classes within classes, instantiating classes within classes, the category class. Today we had the product class. Then we had the laptops that we inherited product from. Remember, we had to import it because it's in a second file, and we went through that. And then we had the shirts, where we also inherited product. And we demonstrated how we could use both the super and the string method that we have defined for a shirt. We talked about multiple inheritance. We talked about the MOR of multiple inheritance. We talked about how to deal with the super call, which refers to the parent in multiple inheritance, where in here we can just simply call. If we needed to make more than one, we could call the name product. We could call the name second. I think, though I'm not sure, that you can, like I said, that you can do something like that. Does anybody have any more questions? I see I missed one earlier for the questions. Can you make a quick recap from the products? Not sure if I did that already in talking about what we went through, but I'm not sure if you could maybe go up and change the wording in the question or add some wording to it, or did I already cover that? I see that somebody dropped an article here. Yeah, and this is another way of doing it that I was thinking of that will work, where you can call super and you put it in the parens. And I guess I forgot to mention you have to put the self as well when you call the super, but this is another way of doing it. That looks like that might be Python 2, because it's talking about here in Python 3 you can use super instead of super type instance. And they're here, right here, they're doing it in the constructor. They're doing it the way I was speaking of. When was this written? 7 years ago. And they're doing it the same way here. And I'm still not sure, honestly, because like I said, I'm not sure that this this will work in Python 3. We'd have to experiment with it a little bit. But I think at this point, I don't really have too much else to cover, and there aren't any questions. If anyone wants to hang around and we can all jump on the mics, we can try to run some of this and experiment with the super, how it works, the syntax, the different string returns. I'll keep recording it. Or you can go experiment on your own. I'll drop the rest of the code that we did today. You've got the code from yesterday up above. So is anybody interested in hanging around and playing around with the code and trying to run it? Or would you rather go work on your own projects, work on the code in itself? It's up to you.
Yo, I got a question.
Yeah, what's up?
What's the sprint challenge gonna look like tomorrow? Is it just gonna go over basically what we did in this past week, or like basically what the project was yesterday?
The sprint for tomorrow, I believe. I'd have to go look. I haven't even looked. I have bounced around. They've bounced me around so many sections. I can't keep these straight in my head. And honestly, I haven't looked at the sprint for tomorrow.
Okay, well, probably along the lines of something like
give me 1 second, and I can tell you. I just don't. It's going to take me a second to get to it. So the sprint for tomorrow, which one is it? Looks like you're going to be doing a little bit of OOP with class hierarchies, subclassing, and method overriding like we're talking about, list comprehensions like we covered, I believe, on the first day, some CSV file reading, remember the open, the close, and all that good stuff that we dealt with. You're going to have test files, the same as we've always done. So there's nothing crazy that I'm seeing in there. Yeah, it's basically just it's kind of like a 101 of the material for the week, the introductory material. So there's not, if you know the stuff fairly well from the week, you shouldn't have any problems tomorrow. It's not one of those outlandish sprints.
Cool. Yeah, I feel like we've covered a good amount this week.
We have.
As far as like getting prepared for algorithms next week, because I know that's going to be like quite the load, what would you suggest that we like really try to cement from this week?
I would make sure that you understand the content of this week, the basics of Python, because something we had, and I don't know if it was good, bad, or really inconsequential. We did a lot of our DSNA in JavaScript because it was totally ordered different. So we got to use the language we were really familiar with. That said, to me, Python's a fairly simple language to deal with, but this is, for a lot of you, your first week in it. So number one, make sure you've got the basics down. You don't have to memorize everything. You don't have to, be able to do it like a pro. Make sure you've got the basics down from this week. And as far as the next few weeks are fairly difficult, not even going to lie. You've got your data structures and your algorithms. You're going to be covering a lot of sorting. You're going to be covering things like binary search trees. You're going to get to the graph week, which is an infamously not so fun week that's got a ridiculous sprint challenge, and it's got a different format to the week. So how I would go about, I would make sure that I understood this week's material. I would make sure I was fairly comfortable in Python. And a lot of that'll still just come. I mean, there's things like you saw today. I mean, I've been dealing with Python a lot, but when you get into questions like about multiple inheritance and what I can't answer them with certainty without going back and looking at things and without getting confused. So just make sure you're up on the basics. I will post the videos on Friday that for the whole week, in fact, and I'll just denote which videos go with which days. If it was me, I would go over all those videos over the weekend, have that done. If you're just looking for basic material outside of that, outside of, hey, be ready for the language, hey, be ready with the pre-class videos, I would just do some general reading in any, it really can be language agnostic, any kind of a computer science resource. Start reading about the data structure, start reading about linked lists, doubly linked lists, things like hash tables will come on much later. Graphs are farther down along in it. Sorts, there's a lot of sorts and searches, binary search trees. And whether you're reading a Wikipedia article or something out of a textbook, just something reliable, something that keeps things fairly simple. I can post some PDFs of some books that I have. Let's see, what all do I have? I've got the grokking algos. I've got the latest cracking the coding interview. I've got an awesome computer science, like 101, 102 type textbook that I think one of the PMs in here gave me back when he was my student, Kai. And I've got one that's actually specifically, it's a computer science textbook, but it's kind of like a cracking the coding, but it's in Python, so it would be relevant to this. Does anybody want me to post those? I also have something called Computer Science Distilled, which is, it's a couple hundred pages, and it's not like a dummy level, but it's kind of a cliff notes of computer science, and it's written in a real fun way. But I won't be able to post those right away because they take a little bit of time to process the PDFs, but I can definitely post everything I've got. I don't know the legality of the copies of them. I think some of them are.
You can just put in Google Drive.
What's that?
Google Drive.
Oh yeah, I mean what I'm saying is it takes a moment. My internet speeds here are kind of crap just because it's Brazil, so my uploads are fairly slow. So I know one of them is like a 700-page textbook, and I'm just saying I can't just hit click right now and it'll be there, but I definitely can put them in there. Yeah, you can get started on your project if you want to go. Anybody that wants to go can go. Everybody can go.
If you can share that, would be great.
Yeah, I'll drop everything that I've got. I've got a specific, I don't even know. Hold on a second. Make sure. What do I have pulled up?
Yeah, I had another question too.
What's up?
Like as far as the project goes, I feel like, well, I mean, is it just supposed to be a bunch of elifs? Because that's literally my entire project. It's just like, I can share my screen real quick. It's just this huge thing, and it works and everything. But like, I feel like I would not want to submit this as, like to my employer, let's say.
Yeah, I like that.
You know what I mean? And I'm
Oh,
gonna
yeah.
add more to it today, so it'll be like, probably even longer of the same thing, just saying, oh, if this happens, do this. If this happens, do this. Is there like a more dry way to code it?
There would be a more, this is what I would do if I were you. Get everything working. Like we talked about a first pass solution. I'd rather see something ugly than something that doesn't work at all. Not saying this is ugly or not. I'm just saying I would rather see something that works than something that doesn't work. I think an employer would rather see something that works versus something that doesn't work. I have a friend that just interviewed at Google, her initial interview there, and she presented some pretty crazy ways of doing things, and she was pretty upset about it afterwards, thinking that she totally bombed it, and they called her back for a second interview, which is, I think they've got 5 or 6 interviews, so it's just barely getting along the way. But I think the point of reaching a first pass solution is more important than trying to worry about at the beginning making it as dry, as readable, as simple, and as possible. Does that make sense?
Yeah.
Get something working. Once you get something working, we can chat in a DM or in the group or whatever about some ways other people have gone about it, or some ways that we could refactor that code perhaps and improve on the code. from there. Okay.
Yeah, sounds good.
Oh, I was gonna look real quick. Hold on. Let me see if I can get out of. What all do I have? I have cracking the coding interview. This is the new one. This is an older one. I've got the grokking algos. I've got the computer science distilled. What is this? This is an introduction to algos book. This is a really, it's very terse in ways, and it's definitely like a college 101, 102 computer science book, but it's an awesome book. This is a good one because it's elements of programming interviews in Python. This is like a cracking the coding, but on steroids, but it's from the Python perspective. So that's why I liked this one. And that's the one that Kai gave me. So I'll just post all of these. And that way everybody will have access to them. Anybody else have any questions? Anything you want to go over? Anything you wanted to do? Nobody? All right, I'll drop the code. I will drop the recording. I will drop all these books. And I will be around for the day if you've got any questions. And we talked about the sprint tomorrow a little bit. So if no one has anything in closing,